Welcome. Welcome to the second lecture of week 4, number 17. So, in this lecture, today let us discuss about the risk as far as climate change is concerned, which is influenced or seen over the terrestrial and fresh water ecosystems. And also let us see what are the feedbacks in terms of the climate change risk is concerned. So, to cover this, we will cover these concepts, which are the 5: synthesis. So, synthesis of observed changes attributed to climate change in terms of freshwater ecosystem. So, we will see with respect to some wetlands, some river system, and also the snow and glacier. So, there we will understand that how much is the rate of change as far as the climate change induced impact is concerned. Then we will go towards understanding in terms of the terrestrial also, and from there on we will move on to the feedback. So, what are the ecosystem feedback or feedback loops are there? So, what does it mean? So, that means when one effect happens, then it has a what you say influence on the next one. So, and vice versa. So, this goes in terms of sometime as a loop or one to the next. So, having understood this, we will also try to see what is the way this terrestrial ecosystem feedback affects the earth climate system dynamics. We will take a few examples and try to understand the risks over the freshwater and the terrestrial ecosystems and their feedback mechanism and how it affect the earth's climate system dynamics. So, before us we have let us understand the trends in terms of river. The upper slide, the upper figure talks about the observed trend in terms of the lakes for the period of 1970 to 2010. So, the observations in terms of the research based studies or investigations where it has been done over some lake has been shown in terms of the dots, and then the dot you can see that itself is actually having a different color gradation in terms of cyan to red. So, and a whitish color or a gray color closer to that is 0, and more of a cyan is towards minus in terms of temperature rise, that means it is a cooling effect, and more of the reddish nature it is going beyond 1 or 1.0 degree centigrade in terms of the temperature change. And as you know, we are comparing this is a observed trend in terms of lakes for the period of 70 to 2010. And then on the right hand side panel, when we are trying to understand this between minus or you say southern latitude of 70 degree to northern latitude of 80 degree, what we are trying to see that perhaps since we have more land mass in the northern hemisphere, so thereby we have presence of more of the lakes in the northern hemisphere, and if we see around 40 degree north latitude, 40 degree or plus or minus another 10 degree north latitude, we are seeing that in case of many lakes the temperature or the observed temperature has gone beyond 1 degree centigrade in that we say that in terms of the temperature rise. So, similarly you can see and interpret the rest. Now, the lower panel or the lower figure talks about the surface the river in terms of the surface water. So, observed trends in rivers for the period of 1901 to 2010. This is over a longer period of about 110 years. And similarly, the depiction also shows that between 40 to 60 the temperature rise has happened more, though the data is from a lesser system or less river system is represented in terms of the data. So, that is why, but what we agree that moreover most of the lake and surface water from the river in the upper mid latitude plus or minus 40 degrees 40 degree north latitude have evidently shown a temperature rise beyond 1 degree, and also there are places the temperature fall also, that means cooling also has gone to the tune of more than minus 0.5 degree. So, that is what is the observation says. Now, coming focusing over the Himalayan tower in terms of the Tibetan plateau. So, let us see the change in the water extent. This is the change in the water extent, which is shown in terms of the percentage of change in water extent during 2000 to 2019 in relation to 84 to 99. So, it is a kind of 15 to 20 years period of data analysis, and then the graph shows the legend shows the variation between plus or minus 10%. So, 10% change in terms of the water extent. It is the extent or the spread of the water in terms of the terrestrial water we are talking to here today. So, this much change has happened in a time period of 15 to 20 years. So, it has gone up to 10% plus or minus. So, plus or minus means at places there also have been rise in terms of this. So, you can see those dots are more towards the what you say terrestrial domain, particularly over Bangladesh and some part of the West Bengal in the estuary of Meghna and the Ganges river. So, that means this can be attributed to little bit of sea level rise, or you say in that way particularly some rise in terms of this. So, otherwise there has been the extent of the water extent over the Tibetan plateau has gone up to decrease in terms of or up to 10% plus or minus. Similarly, let us have a look at the ice cover in terms of the trend, the ice cover trends of lakes. So, here it is the temperature projection relative to 1970 to 2100, and if you see the future changes in terms of the lake that experiments intermittent winter ice cover also, and which is shown from 2 degree to 8 degree plus 8 degree centigrade in terms of the what you say temperature projection relative to 1970 to 2010. So, in totality these 3 slides where we have talked about the lake, the ice cover and also the river water, the surface water, we are seeing that what we understood that the earth has been experiencing lot of changes, but it is in either direction. So, what is the synthesis out of this? The synthesis of the observed changes attributed to climate change in terms of fresh water is shown in two directions in increase. So, the triangle in right condition and the invert condition shows the direction of the change in terms of decrease, and the confidence level goes in terms of the color gradation starting from a pale to a little darker blue color. And let us see what are the attributes and what are the systems has been taken. So, in terms of the systems, these 5 broad system have been taken, as we know: tropical, temperate, boreal, polar. So, between tropical and temperate we have a subtropical zone which is an intermediate zone. So, if you include that, it is tropics, subtropics, temperate, boreal and the polar zone. And what are the attributes in terms of the freshwater ecosystem is concerned? If you see, the first one is the surface water temperature. In all 3 zones, that means all across the world, the surface water temperature has been in rise, and the confidence level is very high because it is represented by a dark blue kind of representation and inverted what do you say the right shape of the triangle itself shows that there has been increase. Coming to the next one is the shift in the thermal regime. There have been a shift in terms of the rise in the temperature in the temperate, boreal and the polar regions. And in terms of the other two, that means the tropic and subtropics, there is limited data to say something conclusively. So, that is why some dotted or a kind of vertical line has been kept there. Now, come to the next one, that is the ice duration. You see, the ice duration is showing a decrease in temporal, boreal and polar. Similarly, in terms of the growing season change, it is also showing a increase in temperate, boreal and polar. So, what you see, the growing season length is increasing because of the warming we are getting more and more area around temperate, boreal and polar regions which are experiencing growing season length, the growing length in terms of the season or seasonal length in terms of the growing phase. Then coming to the next one is the lake productivity. As far as the lake productivity is concerned, out of the data it has been seen that the temperate and boreal lakes, they have contributed to the productivity level has risen, have increased. So, then the in terms of the evaporation, as we can expect that due to temperature rise, the evaporation rate or in totality for all these systems in terms of tropics, subtropics, temperate, polar and boreal have increased or have shown a definite increase, because it is shown with the color that is having a high level of confidence level. So, similarly, other things like ecosystem heterotrophy, the animal body size, all these things people or the scientists are working on. Maybe you can follow more literature if you have a greater details or you want to know in depth. Now, let us move on to the observed changes in the distribution of the PFT. Now, friends, this particular term plant functional type is relatively new to many of us. So, what it is, as you can understand, any structure has its any matter or any feature has both the structural and functional entity. So, plant, you can see it in terms of a structure, what kind of volume it takes, but in terms of the function, what are the functions it performs? It performs everything: evaporation, transpiration, the photosynthesis, senescence, many things, phenological behavior, many functions it does perform. So, based on their similarity in terms of the functions, so plants are grouped to different functional types, which we call in terms of their functional variation, we put them under different PFT or plant functional types for ease of investigation, for ease of analyzing their property, their behavior in groups. The groups is based on the functional similarity or dissimilarity. So, similar plants could be put under similar kind of PFTs and vice versa. So, the different functional types, if you see in terms of the lower left where the lesions have been framed. So, forest cover change in terms of gain loss, herbaceous cover gain loss, shrub and woodland gain or loss, and herbaceous also. And then coming to the temperate biomes, you have temperate broadleaf, temperate conifer, boreal and the kind of grassland kind of situation. So, we have all these kind of different groups or the functional types, and based on the dot, the triangle, filled triangle, and the color with which they are filled, the color by which they are filled, we can interpret what is that particular type in terms of the plant functional, and what is the change in terms of if it is facing towards this side, that means change is there. If it is up, it is gain, and if it is down, it is loss. So, that kind of direction also. So, this is how the complex things are being represented, both using their dimension and the what you say direction and the color gradation. So, this itself what it is shows that all the different plant function types are going through changes. Somewhere it is loss, somewhere it is gain, and many where the still investigation is going on and conclusive things have not yet come. So, that many things could not or cannot be told in conclusion. So, projections. So, the projection of projection fraction of global terrestrial area that could experience a biome shift by 2100. We all have studied the various kind of situations. So, in terms of the projection in comparison to 1850 to 1900 is shown in the x axis of this graph, and on the y axis is the projected biome change in terms of the percentage of global land. So, what will happen, friends? So, in comparison to the base year pre-industrial era 1850 to 1900, if we go on increasing the temperature for 3 degree, 4 degree, 5 degree and 6 degree in the very pessimistic scenario by end of 21st century, then this much of percentage of the biome will change. Will change means it will change from tropics to subtropics or savanna to a grassland and things like that. So, what we try to understand, the first 3 slides talked more, in terms of the inland water bodies including ice, and this set of slides are talking about the terrestrial features in terms of the plants, dominantly in terms of the plants, plant functional types, the biomes and the forest types. Now, when we study or try to understand, is there any risk of extinction? So, that means it goes beyond the capacity of resilience, then it cannot cope up with the climate change, so that it will face extinction, it will go forever. We put it in terms of extinction. So, various studies have shown that the rise in temperature situation of 1.5, 2 degree, 3.2 degree, 4.5 degree, all these things, if there is a very high risk of extinction, and the percent of species at very high and high is shown in terms of the A and B, that means left and right in terms of various color gradations of multiple histograms or cumulative histograms we say. So, plants, the second line, you see it is shown in the x axis between 0 to 100 in terms of percentage, and here also 0 to 100. So, we say that plants may be 1, 2, 3, 4, 5. So, up to 25% it will change in terms of if the temperature goes beyond 4 degree, and look at the invertebrates will go up to 40%. So, all these things have come from different research based studies, and they have been put forth here as far as different groups is concerned. So, in terms of invertebrates, flies, true bugs, spiders, pollinators, butterflies, dragonflies, all these things. So, you have a list in this IPC, the reference is mentioned at the end. So, some of you who are interested to pursue more can read more, because all those references have been cited. So, the message from here goes that yes, lot of the species will face extinction. We all have the single and the very exemplary example, that is the dinosaurs. Okay. So, similarly lot of species will extinct, because they will not be able to cope up with the changing climatic situation. Now, friends, I picked this also a kind of table given in the report. So, this report as an example talks about the global biodiversity loss and the critical factors for that. So, the key risks to terrestrial ecosystems from climate change are coming from these factors. So, as all of us know, the climate factors, shifts in geographic placements of climate space, loss of climate space globally, emergence of non-analogous climates, increases in extreme climate events. Look at the 4 points have been mentioned here. One is shift in the geographic placements of climate space. So, what does it mean? So, earlier let us say you were experiencing this set of condition between 10 to 20 degree north latitude. Now, you are experiencing the same tropical or what you say kind of condition between 15 to 25 degree north latitude. So, what you mean to say, the geographical space or the geographical placement in terms of the climate space has shifted from 10 to 20, earlier it was 10 to 20, now the same set of climatic conditions is available between 15 to 25. So, we call it geographic placement of climate space in terms of the shift. Losses of climate space globally. So, then till how long it will shift? You have up to the mountain top or towards up to the polar region, or you say 90 degree in both sides, north and south latitudes. So, that means beyond that the climate space is not available. So, that means it is lost globally. Then in terms of shift I am talking, but from other point of view also the same place it is not available, because it is a different kind of situation, temperature and other things as we understand is prevailing what it was not before in the same space and the same geographical space. So, that means it is lost forever. Emergence of non-analog climate. So, because of that you get another set of climate. You have a climate which is giving a drought kind of situation, you have a climate which is facing higher temperature. So, because of that the whole set of biota around that will change, and the whole set of plants, animals, their interaction will change. So, a new set of new set of non-analogous climate situation emerges there, and this actually increases and more so. As we already have discussed yesterday also, we are the civilians, the humanity is experiencing the extreme weather events more frequently in recent days. So, that is also the climatic factors. The non-climatic factors are because of this, because of population growth and all these things, we have lot of land use, land cover change, we have degradation in the habitat, for example, from pollution, fertilization and species invasion. What is species invasion? The species which is not required is invading that geographical space. So, we do not want this species, but it is giving a tough competition to the what you say native species, and it is invading. So, we call species invasion. Then the third one is detection and attribution. Already observed many cases of population extinctions, 2 to what you say 92 cases of species extinction have been reported by different groups of studies, and species have tracked their climate niche, raising confidence in terms of the SDM projection. So, species distribution models which takes care of this kind of projection in terms of species related shift or movement, okay, are giving more and more predictive information with respect to individual species based on climate and other non-climatic factors also included into those models. Now, coming to the adaptation, yes, there have been habitat restoration, habitat creation, increased connectivity of habitats and protected areas, increase in protected areas and assisted colonization. These are the adaptation techniques concerned as far as the example of biodiversity or attending to biodiversity conservation is concerned. So, what we do? We restore the habitat, we create new habitats, or we shift new habitats and create in another location. We increase the connectivity of habitats, one patch of forest land to another patch of land. So, that movement of this will happen seamlessly. Then then increase the protected areas, and we also sometimes think of assisted colonization. This group of species, let us take and put it there also. So, we assist them in terms of colonizing in one or the other geographic space based on the climate or based on the new climate suitability. But in terms of the risk of transition, 0.8 degree centigrade undetectable risk to moderate high in terms of 1.58 moderate risk risk have been reported. So moderate to high to very high kind of risk in terms of transition have been reported by various model projections as far as the biodiversity is concerned. So friends, I try to discuss with you this biodiversity as a case or as an example in terms of what are the risks it faces from climate and non-climatic factors, and what are the options we also have in terms of the adaptation. Now, the key risks to terrestrial and freshwater ecosystems from climate change are moderate, high, very high, and something which we call the undetectable, that are represented here using different colors. So moderate, a kind of yellow, and in between red high, and magenta or a dark red is depicting very high, and similarly the confidence level is shown in terms of the black dots. Let us take, along with the biodiversity loss, another 4 different examples of terrestrial features. So one is the structural change, the attribute, the tree mortality, the increase in the wildfire incidences, and also the carbon loss, particularly the forest carbon loss. Okay. So everywhere you can see this is shown in terms of the global mean surface changes relative to 1850 to 1900, and you can see a shadow line in a horizontal line has been shown over 1, where this 1, 2, 3, 4, 5 on the y axis depicts nothing but the temperature, and there around 1 we are putting 2011 to 2022, because we know already that the earth has already received a rise in temperature of 1.1 degree centigrade in comparison to the pre-industrial era, which is mentioned here, that is 1850 to 1900. So friends, now you try to see this in terms of these 5 attributes of terrestrial, even if you say including the freshwater, so terrestrial and freshwater ecosystems. So biodiversity loss, structural change, tree mortality, wildfire incidents, and also carbon loss, all are posing very important key risks to the freshwater and terrestrial water. So it is very well convincing. And coming to the system feedback, as an example we can take the phenology range shift as the system feedback. So increased primary productivity and plant growth with CO2 fertilization will lead to increasing growth season. So that means if this happens, then there will be reduction in terms of diurnal temperature range through evapotranspiration in the mid latitude, and also albedo which is caused in terms of albedo at high latitudes caused by the vegetation greening will increase the carbon dioxide storage in biomass. So that means more cooling. So this is what is called the feedback. You have primary productivity is increasing, more carbon dioxide availability is acting as a giving a kind of fertilizer effect. So more and more productivity, that means photosynthesis or CO2 sequestration, carbon dioxide sequestration, and this if happens more in the mid latitude, that means what? Increase in the CO2 storage in the mid latitude. So more of the CO2 storage in the mid latitude perhaps will lead to a kind of or give a cooling effect in the mid latitude. That is the feedback. So higher temperature, and you have more productivity, higher CO2 availability, which is acting as behaving as a fertilizer, more of a growing season availability or increased growing season length, and then the reduction in the temperature range as far as ET is concerned. So all this lead to vegetation greening, means more productivity. Then reduction in albedo in snow covered regions as canopies become taller and darker, that means warming effect, it will lead to increased evapotranspiration. So that is a key component of the global water cycle and energy balance, which influences the global rainfall temperature and the atmospheric motion. So friends, I request you to go through the range shift. Range shift is nothing but the reduced albedo in the snow covered regions as trees expand poleward. So, that means enhanced permafrost thawing will lead to expansion of insect outbreak range and thereby increasing the forest impact. Similarly, please read about these two negatives, particularly the deforestation which will lead to reduction in the carbon storage, that means in turn warming. Similarly, the forest fire or wildfire are increasing these days. So, that means increased carbon dioxide and aerosol emissions, it will lead to surface warming. So, the feedback as a whole in totality for the terrestrial ecosystem. So, terrestrial ecosystem feedback which affect the Earth's climate system dynamics. So, look at the perturbations and the implications for climate system dynamics for the three global forest biomes. One is the biological mechanism in tropics, the middle set is for temperate, and the end or the towards the extreme right is the boreal forest. And same set of attributes have been taken. One is the carbon, second is the evaporation, third is the albedo. So, carbon, evaporation and albedo have been put or have been shown across different color gradation in terms of increase, decrease or low effect, and strong cooling, moderate warming and strong warming in terms of the color gradations, which is shown at the end. Now, the perturbations: climate, anthropogenic and the mixed. So, what are the perturbations? Phenology shift, range shift, die-off event, insect infestation. The anthropogenic, which is also little bit the deforestation is dominantly anthropogenic these days, but also it may happen because of natural reasons. Fragmentation is dominantly anthropogenic, air pollution. Then mixed, you have a kind of higher composition in terms of shifts and the net primary productivity shifts and the biogeochemical shifts. So, based on this, the comprehensive analytics as far as the feedback is concerned in terrestrial ecosystems is shown here, and the different perturbations over three different forest biomes, that is the tropics, temperate and boreal. So, for this, the second chapter of this book of the IPCC report has been referred, that is in the terrestrial and freshwater ecosystems and their services. And in conclusion, synthesis of observed changes attributed to climate change in freshwater ecosystems. Ecosystem feedback also we understood, and we also understood the Earth system or Earth climate system dynamics vis-a-vis the terrestrial ecosystem feedback. Thank you very much.